We are welcome Hirotsugu and Megumi for the talking about the test automation in scalability. Thank you.
This session is scaling up 25,000 devices.
Yes, so much more. Okay.
Okay. Thank you very much. Again, this session is about the methodology of testing, scaling out NSO to 25,000 devices. Presenters of this session are Hirotsugu Takahashi and Megumi Kawabata from Japan. We are both customer success specialists from Cisco CX, and we've been supporting our customers to maximize their utilization of Cisco SP automation and networking products. All right, let's move on to the agenda. The content. Oh, sorry. Could you please go?
You also have the click.
Okay,
Yeah.
sorry. The content of this session covers several topics. First, we'll start with background information, then move on to the lab setup, and then compare the performance between 100 devices and 25,000 devices. We'll also compare the performance between NSO version 6.1 and 6.4. Okay, sorry. First of all, I'd like to share the background information. When working with our customers, we often receive questions like how many devices can a single NSO instance handle? The answer is not straightforward, and it often depends on various factors such as CPU, memory, IOPS, base OS, the number of services, and the size of device configuration, and so on. And it is challenging to provide a specific answer. However, we can at least test it to explore the possibilities. So main goal of this session is to explain how we test it and share some test results for this kind of questions. We hope this session will be helpful reference for all of you. Okay. Sorry. Sorry, okay. Okay. Before moving on to the main content, here is a little quick disclaimer. Firstly, test results presented in this session do not guarantee NSO's scalability and performance. So please not use our data as a sole basis for implementing NSO. And any user who wishes to deploy NSO must test its scalability and performance in their own environment before deployment. Okay, and we also not responsible for any damages and issues caused any as a result of using our data. Okay, that's all. Let's move on to the lab setup. From here, I'll hand it over to Hiro.
All right. Thank you, Megumi. So, hello everyone. This is Hiro Takahashi. Thank you for being with us. So, let me start with lab setup. Right. So, when we started this testing, the first challenge we faced was how to set up the lab. So, nobody would like to spin up a 25,000 virtual machines, right? So, what we did was we used some virtual routers with the loopback interfaces to fake the devices. Alright, so let me explain a little bit more details. So in the slide on the right side, there's NSO 6.1. So actually we did this test about a year ago, and at the time 612 was the latest one. So that's why we used that one. But don't worry, we also have the result using NSO 644. The latest, the second latest one, right? So we have the latest result. But we have NSO here, and in the middle there's a virtual router. So this virtual router, when we tested, we used the virtual router called IOL, iOS on Linux. That's available on CML now. But if any of you like to try the same thing, you can also use XRD or XRV 9KV or something. But the point is, this virtual router is connected to NSO, and this router has IP address 10.101.0.1. Okay, but the iOS has a feature called a secondary address. That means we can assign another address here. So like say 10.101.0.2, and also the feature is called the secondary. We can configure more than two, right? So we added another IP address 10.101.0.3, 4, 5, 6 up to 200. So one router has 250 interfaces on one physical interface, right? And from NSO point of view, we registered each IP address as a device. So by having this one virtual router, from NSO's perspective, it has 250 routers, and we spin up 100 virtual routers. So 200 multiplied by 100 means 25,000. So that's how we set up 25,000 routers. So in summary, we deployed 100 virtual routers, configured the 250 virtual routers, and 250 IP addresses on the one interface, and they register each IP addresses as a device from NSO point of view, and to avoid any network delay or any issues happened on the network, we set up everything in a single server, and the resources we used was 8-core 634 gigabyte RAM and the local install. So this is not a super rich VM, right? Yeah. And let me show you what we did. So in this session, we cover 3 patterns we did. The first one is 100 devices plus 100 service instances. That's one. Another one with NSO 612. That's one. Another one is 25,000 devices plus 25,000 instances on 612. That's two. And for this session, we did the same test by using 25,000 devices instances with 644. And the other parameters are the same: local install, no HA, Ubuntu 24.01, and the 8-core 64 gigabyte RAM. And I didn't mention. Oh, sure. Go ahead, please. Yeah, sure.
Okay, short question. You stated at the beginning it's depending on the IOPS we have on the system. Your system has which number, or which scale, or which?
That's a good question. We did not check IOPS. I'm sorry, but the point is, we just like to compare each result. So we don't know what kind of IOPS we did. We had, but we can at least compare, right? The conditions are the same.
Yeah, that's cool. But I do not have your server. I have other one, another setup. Perhaps I have it in the cloud somewhere. So I need a number.
Totally agree with you. Okay. Next time I'll IOPS. Thank you for your advice. Thank you. Okay, and I haven't mentioned about the service model. So this is the service template inside the service model that I used. And as you see, this is kind of real scenario. We didn't use a very future line of service model, but we used the service model that is actually used in the POC. And actually, this one was built by the systems engineer Tatsuhiro. Yeah, but we use this kind of service instance. Okay, so before just listening to the story is boring. So let me show you the actual the lab. So I have this live demo. So this lab is running lab in Tokyo actually, and so let me show you what kind of server we are using now. So the first one is Neo Fetch. So as you see here, there are 8-core 64 gigabyte RAM with Ubuntu 22.04, right? And the next one is NIC. So let's see. So as you see, this each NetIO is connected to each virtual router, and I have 100 NetIO means 100 virtual routers are connected between NSO and this virtual router. The next one is NSO version. Maybe I talk too fast. Yeah.
No.
Okay. So this left one is 644 and the right one is 612. And the next one is number of service number of devices. So if we do show devices list, it goes very long. We don't want to do, we don't want to scroll down to the bottom. We have 25,000 devices. And the next one is a service interface. So this service is called SD1, and we got so many service instances. And I'd like to show you what kind of service has been applied to this router. So there's one, get modification. Yeah, so these are the services applied. So as I showed you, this is a very long service model. And the last one is back pointer. So let's see what kind of configuration is there. Maybe
Oh my God.
space. Yep.
Yeah.
No worry. Please type slowly. Config pipe. Yep.
I'm
Display.
really nervous. Sorry.
Yeah. Display service metadata.
Service
Right.
metadata, okay.
So yeah. So let's see a little bit go down, please. Go. Yeah. A little bit go down. Yeah. So you see. So this is a configuration applied to the router, and here 250. So all configuration has 250 interfaces because we have 250 service instances, right? So this is the lab actually working. So before we move on to the test result, this is actual. This is live demo. Is there any command you would like us to type? It's not. It's a great opportunity to do any command on the 25,000 devices or instances. But if there is any command you would like to ask to type, please put it on the slide. Then I will cover at the end if we have time. All right, so let's move on to the test result. So this one, we did 5 categories of tests: CLI, WebUI, API services, and resources. So let's go one by one. The first one is CLI. So objective of testing is to compare CLI performance, and to avoid any manual operations, we use scripts. And to measure time, we use a time command in Linux, and we did all the tests 3 times, and we calculated average out of 3 tests. And these are the script we actually used. So let's check it on the actual environment. So could you show the actual environment? So maybe 01.
Yeah.
So this is the first test item to check how long it takes to do show devices list pipe count on the 25,000 devices, and we use this kind of bash here script, and can you run the run command, and use a Linux time command, right, to avoid any manual operations. And the 644 show devices list 25,000 devices took maybe 8 sec. On the 612, it took 10 or 11 sec. So we did on the each test items. And here is the test results. So let me go through from the top. So the first one is show devices list pipe count. And when we did this command on the 100 devices and instances, it was 0.26 second. And then when we did the same on the 25,000 on NSO 612, it's 43 times longer than 100. But the point is, although we added 250 times of devices or instances, the time it took was only 43 times. So it's not the linear to the number of devices instances, but the NSO is much faster than the number of devices, and this number has been improved on 644. 644 is only 34 times. So although we added 250 times of devices or instances, the time increased was only 34 times. So that's very fast. And we can see the same trend on the show run service instances. 644 was 73 times longer, but the 644 was only 41 times longer. So that means 644 is almost double, not the double, but almost double the performance. And the third one is a sync from for one device. One device sync from and 25,000 devices or one devices. And the interesting thing is the results are almost same. So that means, sync from to one device, number of devices or number of service instances does not affect the performance of a single instance, single devices sync from. And one thing I would like to mention is when we did this one about a year ago, we didn't care, if it was first time or second time. But when we did this time, we noticed that when we did sync from for the first time, it took longer, 2.6. But when we repeat the sync from, the second time or after was faster. Why? Because first time with the sync from, NSO need to establish the SSH session between devices and NSO. But when we repeat that, because SSH session is already up, it's very fast. So this 644, we separated result. So this one, we disconnect every time. Sync from, disconnect, sync from, disconnect. Then it took 2.3 times. And we did sync from and repeated. Then it only took 1 sec. So that means, sync from one device only takes 1 second. And the sync from 100 devices only takes 11 seconds without establishing the connection. So that is very fast. And the live status for 1 sec is almost same. So this is again, number of devices that not affect the performance of live status. So what we can hear this is NSO 644 performs 1.3 times to 1.8 times faster than 612, and the number of devices or instances does not affect sync from or live status for one device, and the sync from or live status performance varies if device is already connected or not. So that's a key takeaway. And the one thing I would like to mention here is when we did sync from for 100 devices, we used a device group. Why this is important? Maybe some of you already know, but the NSO's performance is very different if I use a device group or not. So this is the result. So when we did 100 devices of sync from by using star or asterisk, right? Devices, star, blah, blah, blah. It took 195 times. But if we use device group, it was only a 12 sec. So whenever you need to do any synchron or anything, a user should use a device group. So if a user use a star, that means that expand each device and everything runs in serial, not parallel. So by doing this, it works in serial. This one works in parallel. So whenever you require a performance, don't forget to use a device group. That's a key takeaway. All right, so move on to the web UI. Oh, sure.
Three? Yeah, okay. I'm sorry for so much questions. Okay, that seems to be from the statistical point, okay, because of the devices.
Sure.
But from the reality perspective, you lose all the delay in networks, and you deal with very virtual routers which are very fast on your machine and something like that.
Yes.
I think the normal devices are perhaps a little bit slower. They do different things,
Yes.
which is not reflected here.
Yes.
Can you compare your results you presented here with somehow the biggest network you have seen in the field from your perspective? And is it somehow in the same magnitude, or is it then factor 10, or is it even the same? I don't know. So I'm lacking a little bit the reality of the network.
Okay. So as Megumi mentioned in the at the beginning, we do not guarantee anything. But in my gut feeling, is not 10 times. I mean, maybe a couple of times, or a few times in the worst case, because the factor that's gonna affect the performance will be server, network delay, and the device performance, right? But it doesn't make this performance as double or triple. So maybe a double or triple. That's my gut feeling. Yeah. But a user always need to test if they like the performance. Okay. Yeah. I see. I see. Yeah. Okay. Thank you very much for the good question. Thank you. Thank you. All right. So let me move on to the next one is Web UI. So this Web UI, what we did was compare a Web UI performance, and because it's hard to do any time command or something, this we did some kind of manual task. So a little bit of error are expected, and again these are the result of 3 trials. And let's see the results. So insights, very quick. So what does insights mean here? So this is actual Web UI with 25,000 devices. So maybe could you go a little bit down, please? So you see here's 25,000 devices here, and it's working very good. So can you switch the menu a bit? Say a config editor and go back to tool, tool and insights, tool and insights. See, very fast, very fast. And if you go to devices, it also shows very fast, right? Okay, so that's why what we concluded as quick. And the dashboard, although we had the dashboard until 6.1 or 2, now it's gone, so it's we cannot test. And the third thing is Explorer devices. So this one, actually, we observed some kind of small issue when we did tested on 6.1.2, but now it's gone on 6.4.4. So let me show you how it works. So this is a Web UI, and sorry, it switched the position, but the right side is 6.1.2, left side is 6.4.4. You see a new UI here. So let's see how long it takes when we try to show the devices on this Web UI. Let's start. So on the right side, on the left side, 6.4.4 showed all 50 devices, because in UI we can only display 50 devices. That's the max. But 6.1.2, it took very long. It took 1 minute or 22 seconds to display. So that was very slow in 6.1.2. Now it's improved to only 1 second, 1.7 seconds. So this has been improved a lot. And another way is Explore services. That's okay. And the sync from one device, that's almost the same. All the results are 2.8 or something. But another interesting is sync from 50 devices. Why 50? Because in UI we can select up to 50 devices. So that's why we did 50 devices of sync from. But it was improved a lot. It used to take more than 1 minute, but now it's only 13 seconds. So let's see how it works. So this is the Synchron 50, sorry, this one. This one is Synchron 50 devices. Now I check everything, 50, 50, and if the number is large, the new UI shows, a large, it's a very large number. Do you really want to do it or not? And I clicked yes. And in UI, it only took about 12 to 13 seconds to sync from all 50 devices. But in the old UI, I like these colors, and maybe these colors are the reason, but it took 1 minute 29 seconds. So that was very long. Yeah, so in summary, Web UI performance has been improved a lot in NSO 6.4, and the Explorer devices is very fast in NSO 6.4. And the sync from devices, in point of view, it's almost 7 times faster in 6.4. So that's the result of Web UI. Right, so sorry, let's move on to the next one. So next one is RESTconf. So RESTconf, what we did was compare the RESTconf performance, and then let's see what kind of script we use. So Megumi, can you put the
Yeah, of course.
the script? So for the REST
Wait a
comp,
moment.
why it's not showing? So REST comp,
Wait a moment. Sorry.
no, that's okay. Yeah, so what we, instead of using here text on in bash, we use a curl like this. So it's very simple, right? So use curl and use time command to test. That's very simple. So here is the result. Here are the results. So RESTconf, we did only 2 items. I don't know why it's not much, but there. To get a device, it was 0.7 in the 6.1, but now it's 0.3. And the get service, it was 0.03 to 0.08. So the interesting thing is number of devices does not affect API performance if you get one device or one service, and that performance has been improved in 644 almost 2 times. So that's a very good result. And next one is services. So services, what we tested was dry run one service, apply one service, and delete one service, and dry run 100 services, and apply 100 services, and delete 100 services. And the improvement we observed was this first one. So when we did a dry run, apply, or delete for one services, there was no difference between a number of devices or instances, but the 6.4 performs almost 20% faster than 6.1.2. So that's a good observation. But when we did 100 devices, the results are the almost same. So in conclusion, NSO 6.4 performs 10 to 20% faster than 6.1.2, and the dry run applying deleting one service is not affected by a number of devices or services. That's the conclusion. And the last one is resources. So what we tested was, how much resources NSO was going to consume. When we set up 100 devices and instances, a total CDB memory in memory was 8 megabyte and 1 megabyte on disk. But when we increased the number of devices and instances to 25,000, it was 1.2 gigabyte memory and 256 memory on disk. And actually, this number was worse on 644. Although on 6.1 it was 1.2 gigabyte, now it's 1.9, and on disk 257 megabyte to 476 6 megabyte. But I guess to set up this lab, we migrated. We did version up from 6.1 to 6.4 with 25,000 devices and instances. So my gut feeling is there could be some garbage in the memory or disk. Maybe so if we set up 644 environment from scratch, maybe we could have a different result. But keep upgrading NSO is the real scenario. So I just wanted to share what I have observed. And the boot up time is a little bit worse, but the memory consumption is almost same. So in summary, we observed large CDB size consumption in NSO 6.4 when we upgrade from 6.1 to 6.4, and the other values there are not much difference. And when we talk about 6.4, I think everyone would like to know, right? We have a new feature. Sorry, we have a new feature called in memory and on demand. So I did a test. So I think most of you are familiar, but let me quickly describe what kind of feature is. So this in memory is the feature running on NSO by default, meaning everything runs on memory. Everything runs on memory. But from 6.4, we have a new feature called on demand. That means we can offload some data to a disk to save memory, right? So let's see what kind of result we observed with 25,000 devices and instances. So 644 in memory, everything in memory, it consumes 1.9 gigabyte memory and 472 megabyte on disk. But when we change to on demand, 127 megabyte. So this is not typo. 127 megabyte memory and the 950 megabyte of the disk. Because NSO offload some data, we consume more disk, but the 127 megabyte memory is, this is, so surprising. And the boot up time is improved, and the memory consumption in the actual usage is also improved. So by using on demand, we can hugely reduce memory consumption, and the boot up time is also improved. And I just wanted to show the screenshot so that so this number is not a typo, right? 127 megabyte, right? So this is amazing. Okay, so these are the results we have. But we still have 10 minutes. We have one more bonus session. That is, as I mentioned, we upgraded NSO from 6.1 to 6.4, and we spent a hard time. So let me share what we faced. So to prepare this session, we upgraded NSO from 6.1 to 6.4 with 25,000 device instances, and there's a caveat in migrating NSO, migrating net IDs. So let me share that one. So I hope everyone knows the steps to upgrade the NSO, right? So when we upgrade, first of all, we need to first of all, we need to find out net to migrate, and we use this kind of command to switch the net ID, then remove all the net, stop all the net, run your NSO, and they make and they load and they run NSO with packages reload option. That's how it works. And this is what I did. But this is not recommended. Especially this red part. Why? Because as I mentioned in CLI, if you use this star or asterisk, it expands in the shell and it works in serial, not parallel. So what does that mean? If we use star, migrating one net was 8 sec, 10 device was 86 sec, 100 device was 78 sec, 25,000 devices 3 days, and I actually did. I wait 3 days, and after that, Megumi said, "Well, why why are you using this? You should not use the star. What? You should, you should tell me, before." So I did test both this star and not star, and this is the result. So if we do net migration using star, it takes 2.4 days. But if we use just devices migrate, not the device, but devices migrate, or if we use a device group, migrating one net only, migrating 100 devices only 10. So this is the result of migrating 100 devices. And if you use star, it was 800 seconds by using star. But if you use this device group or something, it was only 36. So that means we can migrate 25,000 devices, with only 2 hours or so. And she did multiple times, and the result was almost 120 minutes to 130 minutes. So you don't need to wait 3 days, but you just wait 2 hours to migrate everything. So whenever you migrate faster, do not use the star, but use devices or device group command. All right, so in summary, I think this will be available somewhere, so I just summarize all the results. And here are key takeaways. So number of devices or instances does not affect action to single device or services. And compared to 6.1, 6.4 performs 20% to 100% faster. That means the performance is almost double in CLI and 700% in WebUI, and avoid using wildcard expressions when a fast operation is required. And all right, so we still have 5 minutes, and that's all we have now. And any questions, comment, or any other idea, any other test items to test, or any better way to testing, I like to know that. Oh, here's the one question.
Hello. So just a question.
Sure.
So, when we're changing something like on the template config and we want to redeploy all the services again, I think like using the asterisk is never good. So what we should do in this case, how can we redeploy thousands of services without using asterisks?
So if that thousand of devices are all devices, then you can use a devices something command. And if it's not, my recommendation is to create a device group, just for the purpose.
But in service itself, so we have
Oh,
service that
oh,
manages multiple devices.
services. That's a good question. Maybe so. Okay, let's grab some developer and ask them. I'm sorry, I don't remember.
I think one of the developers will give you a definite answer, but there's a touch command that you can use in the configure mode, which I think should invoke fastmap to run on all the services you need, and then I think you could do it with that, but you should talk to one of the developers.
Thanks, Blas.
Do we have more questions here in this room?
How should customer test if Cisco is not responsible? Oh, see this group. Okay, yeah. So so the reason we put the disclaimer is the condition varies. Depends on the customer. So as I got question, this is one example, but no customer has the same environment. So if any customer like us, Cisco, to do any testing, the customer can use the services. And actually, we are from CX, and we do have a testing services. So we can offer testing services, and we set up the lab for the customer, under all the requirement, and they do test for you. So if that kind of service can help, please ask our Cisco CX team. So we are more than happy to help that customer. Thank you for the question. And the next one is not depending of the lack of the devices. So
I have the same question.
Location of the
So
device.
that's lines of code in the device.
Oh, lines. Oh, yeah, yeah.
And the question we have routers with 20,000 lines of commands in there, and you have a very small service. So how is this influencing the performance, especially if I go sync against services or sync the whole device? That's differently than having 100 lines per router.
That's a very good. That's very good point. Maybe we should add another item. Then a number of the line of configs, and they do. They perform a sync from or a show command, and how it works. So, but I also have a question. So when we talk about the line of config, doesn't mean that the configuration is within the service instance or outside of a service instance.
Some of the guys who has this routers in our company told me there's a total number of lines of config on the device, and it's split up in several services. That's not in one service.
Okay.
Yeah, that's not so big, but you have hundreds of VPNs, then you will end up in such a big configuration.
Understood.
Routers running fine.
Understood. Okay.
That's how is NSO performing.
I see. Thank you for sharing a real scenario. We'll consider adding that item next time, if you have time. Thank you. All right, any other questions, comments? Yes, please.
Yes, you tested this version of NSO on bare metal, I think.
No, this is actually VM.
Okay.
Oh, yes.
But would I expect a similar performance if I was using NSO in a Docker container?
Yeah, I think so. Yeah.
Thank you.
Yeah. Because in Docker container, the containers are the same, right? So I think the performance between container and VM shouldn't be different, right? So maybe we should observe the same kind of result here.
Hello.
Hello.
You show us in the presentation that there are two new modes. In memory and on demand. And you said that on demand is faster, but is faster in all the operation or directly you recommend to boot it on demand and forget the in-memory mode or what do you recommend?
That's a very good question. So actually, because we not able to complete all the testing, so that's why we haven't shared it. But we did some tests on this on-demand mode, and what we felt, not exactly measured, but what we felt was the first command took longer than the memory mode because it access it access a disk, load the memory, do right. So if you have a few instances or something, that's very frequent access, then this on-demand mode should work. But if you have so many instances or something that is offloaded to the disk, then maybe we should expect a little bit of delay for the first transaction. But also it's your choice. If you like to reduce the resources, or if you like to reduce the time to complete. If you are okay to reduce resources with a little bit longer time, then this on demand should be an option, I think.
Okay, thank you.
Thank you. All right. Any other questions or comment? We are almost time, but maybe last one. Okay, if not, maybe we should close.
Yes. Thank you very much.
Thank you very much for being
Big
with us.
applause.
Thank you.
Thank you very much.